rather than how, I will try to explain the why question here for most of the topics that I'm going to actually cover today. So I'm going to start with the history, and we are going to go from there. Like, I'm going to try to give you an example of a kind of like a fake company I created, how to use the Cosmos DB and what they need to kind of pay attention to. And if you have any questions, please, you can ask me probably at the end of the session, and I will answer any of the questions. Before I go in the presentation, let me talk about myself. I'm from Cleveland, Ohio. Right now, I'm working as a business intelligence manager at Progressive Insurance. And currently, I'm Microsoft Data Platform MVP. This is my second year, and I'm very happy and honored. I've been doing web development 15 years, and almost 8 years I'm doing the business intelligence on top of that. So if you will have any questions, you can ask me now, or if you can, if you come up with a question later, you can follow me on the LinkedIn or Twitter. I'm pretty active out there, and I can answer any of your questions from there too. I have a blog. I write about Cosmos DB a lot out there, but rather than Cosmos DB, I still share like the front end, C#, and SQL Server. So whatever I know, really, I like to share in my blog. Check it out. You might find something that you like. So that's me, and let's actually start the presentation. As I said before, I'm going to start with the history, like for most of the beginner levels. So in 2010, Microsoft came up with this project named Project Florence. The main reason they came up with this project because they needed a NoSQL database internally to share data for their products. If you think about it, Microsoft has these huge products. For example, there's Xbox, there's Office, there's all kind of like large OLTP applications, and there are users in all over the world. So they kind of need to share the data, and unfortunately, they cannot use a schema because depending on what they are sharing, they needed a NoSQL database. So SQL Server was not going to cut that. In 2010, they started a new project, and in 5 years, actually, they had a great product. And in 2015, they were agree on say that okay, this product is stable. Let's share with public, and let's make money on it, right? So in 2015, they actually published this new server, and they call it Azure Document DB. This was the server for developers to store JSON documents on the cloud and retrieve the data from this server. They had to use a language very close to T-SQL. So many people already know the T-SQL, so people like it, and people start to use it a lot. Microsoft didn't stop in 2015. They continued developing this, and Cosmos DB, became really the backbone of the Azure. Most of the products are using the Cosmos DB. So in 2017, they came up with many new features, and I guess the biggest change was the name. They changed the name from Document DB to Cosmos DB. Also, they introduced like global distribution, multi-model, and many features in 2017. Well, after 2017, every year they are actually, giving us like more features every year. So 2020 came, Corona came at the same time, and Cosmos DB did not stop. And in this year, actually, last year, they gave us the serverless and auto-scale options. In 2021, let's see what they're going to come up with. I'm curious. The Microsoft conferences are coming up, so let's see. Hopefully, you will see something exciting from the Cosmos DB. So the first question I get from many people is, like, who is using this product, or in what situation I should pick Cosmos DB rather than SQL Server? So I kind of categorize those to 3 categories. The first one is the entertainment, like gaming. So in old days, when I got a game, it used to come up on a CD. You put in CD, you install it, you are done with it, right? You pay like $30, $40, and you own the product, and you will play until it ends. But now the games are different. You pay all this money, $50, $60. On top of that, you start to play the game. If it's a racing car, for example, they might try to sell you a car in the game. or they might try to sell you parts so your car will go faster, or whatever. So they still try to have those transactions going on. They still try to get money from you, and you need some kind of system to do that in the games. And the user can be in anywhere on the world, so it's like a global database. Cosmos DB fits for that perfectly. If they don't want to sell anything, they might have those, all of the games are right now, online, people plays online. And you kind of need to give like, who is the top 10 players, who are the players you are playing with. So you kind of need, that data has to come from some kind of database. So Cosmos DB really fits for that perfectly. The second one is the retail services. So whenever you try to sell something, well, your database is very important because usual database is the bottleneck. And when the special days comes up, like Black Friday, you might be, selling 1,000 items per day, and Black Friday comes up, you might need to sell 10,000 or 100,000 items. Your application needs to be able to serve that many users. Your servers, the database servers, needs to be able to, handle that. So Cosmos DB is great with that because it's very easy to scale up and scale down. Because after the Black Friday, you might need to go back where you were. So if you try to do, selling anything online, Cosmos DB is great for them. Third one is IoT devices, and IoT devices are all over the world, and they are probably responsible of the big data, right? Because they are creating data every second. They are sensing something and they're just sharing it. So usually they don't have schema because depending what kind of sensor is coming from, you're not gonna have one schema for it. So they need a NoSQL database. In the meantime, they can be really in remote locations and they just constantly sense the data. So you need like not just like database, but you need a platform which you are going to actually get this data. Then you are going to save it somewhere. And also you want to analyze this data. So Azure actually makes perfect sense for IoT solutions. So Cosmos DB is used in IoT devices a lot too. The question I get about Cosmos DB, why do we need another database? Don't we have enough databases out there? Do we really need another database? That's a valid question. And to kind of give you an answer for that is we kind of need to figure out, what is really happening in technology. So in 2000, I believe 17, IBM came up with this kind of research, and they find out that in 2 years before 2017, so 2015, 2016, we managed to generate 90% of data on the Earth in 2 years. That's a crazy number of data. So we need to store this data somewhere. And for example, the numbers you see in the right side here, those are the numbers what happens on internet per day. So look at, for example, the Twitter. So 500 million tweets. How many of you actually think that say Twitter uses SQL Server for that? That's not going to happen. So we need another type of database here. And Microsoft did not have a NoSQL database before, so they needed to come up with a product like Cosmos DB. And everything's going to Azure. It's going to be a cloud friendly. So that's one of the main reasons we have Cosmos DB here. Also, our users change, right? So now in older days, we don't have that much data. Well, our users are creating all kind of data. So that's funny, but actually that's the reality, that picture. So we have a lot of data. Most of them might be useless data, but we still need to analyze this data. We still need to store this data somewhere. So that's another reason that we need another kind of database system which can handle all these things. Also, we have different device types. So you might have one application, but that application has to run in tablets. It has to run on the cell phones. It has to run on the desktops. And depending what type of device that is, your application might kind of, change a little bit. For example, if it's going to work in cell phone, then you have a GPS chip on it. So you might need to actually start to generate more data because you have the GPS and you might want to track what's really happening or where the user is going. And also customers are expecting more now because, in older days, we used to have like an enterprise, you go to your company, you used to have like this gray kind of grid, it kind of tells you what to do. It was kind of boring, right? But now, if you think about it, all of the customers, all of the users, are used to all this kind of shiny applications because everybody has Facebook and everybody has a Twitter account. And when they go to work, they end up with this gray kind of grid, and it's kind of boring. So people are actually expecting more now. Also, the applications, because of that, applications are consuming more data and they are trying to do more stuff for users, and they generate more data than before. Also, the globalization is real. So if you are a developer and if you solve a common problem and you kind of go and share this application in one of the stores, in Amazon store, Microsoft store, wherever, next day when you wake up, you might end up with users from all over the world, right? Which is great, but hopefully you pick a right database for your data, so that your application can handle all these users. So globalization can happen in anybody. So you need a database which can actually handle all those things. So what I'm going to actually show you here is, let's talk about I will give you a business example. And this page here, actually this used to be from the Azure. I'm sure they have more data centers now. Each dot here you see is a data center. And really, if you think about it, whenever you try to create any kind of Azure feature, this is the first page you come up with, right? You want to kind of pick the location. Where is this application or feature is going to actually stay? So let's say we work in a company and we build cars, right? And we are located, let's say we are located in Europe, somewhere, Central Europe. So we have a great competition going on because all of the other companies, they are creating all these smart cars. They are creating all this. The cars can drive themselves now, and you can send messages and receive messages to cars. So there's all kind of stuff going on. And we start to feel kind of, I guess, nervous. We say, okay, let's jump in that ship and let's maybe for one hour model, let's make it, a smart car. All we want to put some IoT devices in it so we can receive and send messages to the car and give a user, I guess, our customer, a better kind of environment. So that's the idea. So we hired a dev team and we talked with the dev team, and they figure out very easily that we are going to need a NoSQL database here because we are dealing with kind of big data and our customers are all over the places. So they say, okay, we are with NoSQL database for this. And they say, well, you know what, let's give Cosmos DB a chance. So they go and actually create the account. And when you actually create the account first time in Cosmos DB, it's going to ask you one big question. And that question is, which API are you going to use? Are you going to use SQL API, Mongo API, Gremlin API? So when you're in that area, you should already know what you are trying to create. But in our case, this is a whole new application. For the whole new application, Microsoft will suggest you to pick SQL API. The main reason for that is SQL API is the most advanced Cosmos DB's API because Microsoft is in charge of it, and they are the one who is actually adding features into it. So if you're going to need something in feature, you might have a chance to go to Microsoft and ask for it. If you're going to pick something else, Microsoft might not be in charge of, for example, MongoDB, right? So if you're going to ask for something, you have to go to MongoDB, not to Microsoft. So I will suggest you to pick SQL API if this is a new project we are starting from scratch. As soon as we create the database, we are going to end up with 99.99% SLA with only one location and with one database. That's a great number. So from that point, our dev team start to kind of investigate and try to figure out, okay, where's our customers? Where are we selling this product first? So they find out that most of the products we are selling is in the United States, in Europe, and some in Asia. So those are the three places that we are going to have a lot of customers. They are going to try to read and write data. Now, you might feel a little bit nervous in here because, first of all, we don't want users from the United States, right, to route data to Europe. It's just like there's just a big kind of like the lag of it there. And same with the Asia. Whenever you try to read and write, that's not going to work. We check the Cosmos DB. Actually, Cosmos DB gives you a global distribution, which means that I can actually pick other data centers close to my users. And the users in United States, if they are in, let's say they are on West Side, my SDK will actually sense that I have a data center right here, and I will use this one to write and read my data. So the team decided to say, okay, we are going to have 4 databases, and we are going to put them into this East data center, West data center of the United States. We already have 1 in Europe, and we are going to put 1 in Asia. So depending where the users are, they are going to actually access wherever is closest to them. So that's great. And at the end, what's going to happen here is whenever you write the data from United States, Cosmos DB is in charge to sync this data to each data center. So each data center will have the same data. As soon as we actually pick these items here, pick the data centers, and click update, it really depends how much data you have in that case. But usually, if you have like less than 1 terabyte, probably in 30 minutes, all of the data centers will be online and it will be good to go. And as when everything becomes online, our SLA is going to get better too. So our SLA is going to get 99.999%. So almost 100% there. So which is great. So what else do we know about Cosmos DB? Cosmos DB is not like SQL Server, right? In older days in SQL Server, you get a DVD, you put on the CD drive, and you click the next button, God knows how many times, and you customize the SQL Server. You know exactly where the files are. You can do everything. That's not in Cosmos DB. But what do we know in Cosmos DB? First, we know whenever you actually try to save the data is getting saved local SSD drives. So we know that it's fast. Also, what else we know is the file is getting saved in physical partition. So in each physical partition, depending how much data you have, you're going to have X amount of physical partition. The first thing you need to know about physical partition, you have absolutely no rights to change anything on it. So Microsoft manages it 100%. So if you try to go a little bit deeper in this physical partition, each physical partition has a replica set in it. And that kind of, I guess, the picture tells you why Cosmos DB is very fast. Because it's an application, right? And if you are trying to get the data from one partition, you have 4 locations you can hit and get your data, depending on what console system level you pick. So that picture actually tells you like why Cosmos DB is pretty fast. So this one, there are 2 other things that you need to know about the physical partition before I move on. And those 2 numbers that you need to know is, first one is 50 gig, which means this one physical partition can store up to 50 gig data. If you have more than that, you're going to end up with another physical partition. So that controls the number of partitions. And the Cosmos DB will not wait until the 50 gig. I will say probably 70 or 75% when it gets full, probably it will start to create the second partition. And what's going to happen here is you're going to have one full physical partition. The second one is going to be empty. So Cosmos DB in the backend is going to try to balance and move some data from the first one to the second one, so everything will be balanced. The other number you need to know is 10,000 request units. Request units is the currency of Cosmos DB. So that's how you actually pay. And you actually set that up when you are setting up the Cosmos DB database. So 10,000 request units is the limit of a physical partition. So for any reason, if you need more than 10,000, let's say you are going to need 12,000 request units for your application, even you don't have 50 gig in this physical partition, you will still end up with 2 physical partitions because one physical partition can handle up to 10,000 request units. So those 2 numbers are important. Also, other thing important, as you can see in here, it says without global distribution. So this model actually fits if you don't have any kind of global distribution. If you have, in our case, we have, the model changes a little bit. In here, for example, in our case, we have Europe, United States, and Asia, right? So as you can see, what changed here is one of the followers in each replica set becomes a forwarder. That's how actually Cosmos DB, I guess, syncs the data in the backend. So the data actually comes in to the leader. Leader shares all the data to the followers. Then when forwarder actually gets the data, it shares whatever is changed or inserted, and with the other leaders in the other data centers. So that's how actually Cosmos DB syncs the data in the backend. So this is usually the moment I get the question, like, what actually if a conflict happens? Conflict happens in any databases. So you might have an insert, replace, or delete conflict. So maybe the user from Asia and the United States is trying to write the same data in the same time, right? Which one Cosmos DB, how Cosmos DB is going to handle that? When that happens, a referee comes up from nowhere and says that, well, we have a problem here. If you don't change anything, what's going to happen is the last write wins rule is going to go and get the latest data, and whoever write the same data last time will win it, and you'll just ignore the other one. That really doesn't work for many businesses, right? Many businesses have this complex logic, and whenever you try to, if you have the two data coming from the same place, you want to be sure that you are picking the right one. So if that is the case for you, you can go to the custom option. How custom option actually works is you write your own store procedure, which you put all your business logic in it, so you can kind of check every kind of node of the JSON document and make a decision in some way. And then you are going to actually register that store procedure as a merge store procedure. So what's going to happen here is when a conflict happens, that conflict is going to go in a queue. And from that queue, the store procedure is going to pick and run them each time. And it's going to solve and figure out which one is going to be which data we are going to trust, which one we are going to throw. So you're going to be in full control of that with the store procedure. Next one I'm going to cover here is the storage engines. We used to have only one storage engine in Cosmos DB, which was the transactional storage. So it doesn't matter which API you use. Whenever you throw some data to Cosmos DB, that was going to go to the transactional storage, and that was a raw store, transactional storage. When I say raw store, as we can see in this picture here, we are saving the data row by row. So this works great for web applications, right? Usual web applications, you don't try to analyze the data that much. You have like an ID, you search by ID, you show on one page. So you don't try to get like huge amount of data and try to analyze it. So that works for web applications good. But when you try to analyze the data or you try to write a report using your Cosmos DB database, then the thing's getting a little bit kind of, I guess, expensive, let's say like that. Because databases in raw store, everything is saved by row, and this can get really kind of expensive if you are trying to analyze the data, trying to write reports for the Power BI. It gets expensive. So Cosmos DB came up, I think it was last year, with a new storage system named Analytical Storage. And this is by default, it's not enabled. So you have to enable that if you want to use that. What happens here is all of the analytical storage is actually getting saved as a column store, which means that, as you can see, we are actually saving column by column. This makes the aggregation much faster because everything is, saved right in the same location. It's much easier to figure out, get the average, sum or minimum maximum is much easier to find by the disk. So it gets much faster. Also, the getting data from analytical storage is cheaper than getting from raw store. So it's much better if you're analyzing data if it's coming from the analytical storage. So if we try to kind of look at this analytical storage a little bit, the best thing about the analytical storage, I don't know about you, but I have a lot of SQL servers right now in my environment. And We have OLTP and we have reporting, right? And we are in charge of moving data from OLTP to reporting. And usually we use SSIS for it. SSIS can be really pain. They can fail for no reason. It really doesn't matter how good your code is. Because of network, it might fail. Because the database might not be there, it failed. It's just not stable. And in this case, Cosmos DB is responsible to move my data from transactional storage to analytical storage. So I don't need to do any kind of ETL here. And Cosmos DB really depends how much data you have. They kind of guarantee the data will be in analytical storage in 2 to 5 minutes. I mean, in my experience, if my data is small, I would say in 30 seconds, probably it's there. I think they're just trying to be safe out there by just saying 2 and 5 minutes. But that just itself is great. I don't need to write any SSIS packages. My data is there. It's almost like real time. I can actually analyze my data and report my data easily. Just like the OLTP, analytical storage is globally distributed. And that gives us a great, isolation between the OLTP and analytical environment. And as you can see, the prices here, you can I guess it really depends how much data you have and how much data you're going to analyze. But it's much cheaper than try to analyze data in OLTP database for sure. Now, if you compare this to in transactional storage, we have logical partition. We just covered the physical partition. I'm going to cover the logical partition a little bit. But for each logical partition, there is a limit, which is 20 GB. In analytical storage, you don't need to worry about that. The APIs is getting, write their data still the transactional storage. And if you want to read the data from the analytical storage, you need to use the Synapse analytics. Default time to leave property is very useful in Cosmos DB, and it's mostly for retention or caching the data. So if your business is going to say that, I don't really care about this data after 2 years, you can come here and say that default time to leave is 2 years. And after 2 years, Cosmos DB will be responsible to remove that data from your database for free. That works with the analytical storage. You can say that, okay, this data is going to go away 2 years, but in analytical storage, I want to keep this data 5 years. And you can do that by just passing the 5 years to column store turn to life. So those are great options for caching or retention for sure. Now, if you look at the Cosmos DB, like on a paper, so what do we have here is first we create a database of Cosmos DB. Each database is going to have one API, and those are going to be in containers. So that's kind of the first question you need to answer. And your options are SQL API, MongoDB, Cassandra API, and Table API. So each container, it doesn't matter which one you're going to pick here, we are going to have store procedures, user-defined functions. These two, the first thing you need to know is those are in JavaScript. So you have to know JavaScript to be able to create store procedure or user-defined functions. Also, the biggest difference between the store procedures and user-defined functions is store procedures runs only on the leader in that replica set. What that means is leader is always busy getting the new data, updating data, deleting data. So, and also it runs the store procedures. That means that if you are trying to create store procedure to get data, that is not really a good idea because leader is already busy and we have all those followers, right? Followers, you should try to get the data from there rather than leader. So store procedures are good if you are inserting, updating, or deleting data. Well, you cannot delete data, but you cannot update the data. And user-defined functions actually can work in anywhere. So if you are using like if you are trying to get the data, then I will go with the user-defined functions. Next one is triggers. And triggers, we have two types of triggers in Cosmos DB. One is a pre, and then second one is post. If you compare the triggers to SQL Server, the biggest difference is in SQL Server, triggers getting fired automatically. And in Cosmos DB, you have to do that manually. from the SDK. Merge procedures and conflicts, those are that I just covered. Whenever there's a problem with the conflicts, you have the store procedure, you register as a merge procedure, and you kind of handle the conflicts like that. Also, in the right side, we have items. So the items, we call it items here because it's kind of, the naming kind of depends on what API you pick. So if you pick, for example, SQL API, you're going to call your data documents. If you pick the Gremlin, it's going to be nodes and edges. And table API has rows. So those changes you will see mostly in the REST API if you are using it. The URL is going to change and the name is going to change like that. All right. So this slide actually shows you we have some system-defined properties. So those properties exist for every data in Cosmos DB. And the first one is _RID. This is the unique record ID. The second one is ETAG. I'm just going to pass that for now because the next slide is going to actually show you what that is. Mostly it's optimistic concurrency control. _TS is pretty important one. Just shows you the last time the data is updated for that item. Under self is addressable URL. If you're using especially the REST API, if you just take that self, you kind of have a pinpoint where this data is, and you can get and update data by the REST API. ID is the only one you have kind of right to, I guess, override it if you like. And for example, if you have a container named orders and you want to make the ID order ID, you have that chance whenever you are trying the container, you can say that ID will be overwritten by order ID. So in the bottom here, you can see the examples, for example. And the example I'm going to show you here, for example, let's say the self, for example. As you can see, DBS here is containing, it's telling you what the database is. This is the database ID. And this is the collections. This is the collections record ID. This is the documents, and this is the documents record ID. As you can see, this number or this text matches record ID perfectly. So this almost pinpoints where this data is itself. As I said before, I'm going to cover the ETAG right now. ETAG is mostly for optimistic concurrency. So if I get the, let's put the optimistic concurrency definition here, but if I try to explain that, I guess, in a little bit, let's say, for example, in SQL Server, right? So we have the table, and let's say we have two users, and they are going to try to maybe update the same data, and they have no idea that they are trying to update the same data. Let's say we have maybe we are going to update the credit cards limit of a user, right? So two people open the same persons, and they are looking at the same data. So let's say user one updates it first, and user two has no idea because they open the same time. User two doesn't know what has changed. So user two clicks the update, and what's going to happen in that situation? So it really depends on the dev, how they program the application, because database has nothing to do with it in SQL Server. Usually what devs do in that cases like that is usual tables has like updated date or updated by kind of columns. So what devs does is they get the update date and they take it to front end and they hide it under that form that people see. And when they click the submit, they still have that date and they post it back to SQL Server. And before they actually update the data, they kind of compare update date. If the update date matches perfectly, then that means the data does not, change, and we can go safely change it. If update is going to be larger than what we have, then that means somebody else, already updated. We might need to go back to user and say that, well, we have an issue here. Please get the data and check it out again. So as I said before, all that logic happens in kind of like in the middleware. Devs are responsible for it. SQL Server has nothing to do with it. Cosmos DB, it actually can do all that logic itself, and it's using the ETAG for that. What does ETAG actually, if I go back here, as you can see, ETAG is kind of like almost like a GUID data here, right? So what's really happening here is it supports 3 operations. and you are kind of giving a condition. If you're going to use the, for example, if match, then this works only if you need to update data or delete data, and you are going to pass the e tag. If e tag is actually matching perfectly, Cosmos DB will accept that data, and you will have a success message. If the e tag is not going to match, then that means somebody else changes data, and then Cosmos DB will be the one which is going to actually throw them to the user. And I think that error code is 412, HTTP code 412. And that's if match is the most common one. If non-match and if modified, since they are still there, I didn't see that many people use them that much. And I tried to explain what that is. If non-match is usually for getting the data. And this is mostly for, especially browser uses that a lot, not for Cosmos DB, but if the data doesn't change, browser doesn't want to go to the server and get the same data again and again, right? So in that case, we are using if non-match. And if it's not matching, we don't go to Cosmos DB to get the data. It's cached. We can get it from there. And if modify since is from the get, and you actually pass the date here. And if it's not modified since then, you get a date, and that works like that. All right. Next one, which I don't really have that much information here because it just talks for itself. Many companies, might be looking for compliance. If you're in the United States, we might be looking for HIPAA, PCI. As you can see, there's a compliance list of Cosmos DB here. So this is just for the reference, really. Let's look at partitioning. Partitioning is pretty important in Cosmos DB, and probably it's the first curve you're going to take in this race. Hopefully, you're going to take it nice because really your position might depend on how well you take this curve. A lot of things can go wrong with partitioning, and you can really need to understand and why it's important. The most questions I get when I start to talk partitioning, one of them is, oh, does it works like primary key of SQL Server, isn't it? Not really. Primary key in SQL Server, it just makes the row unique. So you won't have the same primary key again and again. And on one of the advantages it puts an index on it. So really, Cosmos DB's partitioning doesn't work like that. How about the table partitioning if you compare SQL Server? Similar, but still, we have I guess in table partitioning, you take or wait your data to get really large, then you start to partition. Cosmos DB is not like that. You have to write the partition ID before you have any data. So what can go wrong in this if you pick the wrong partition ID? As I said before, we are going to talk about the logical partitions. And logical partitions has 20 gig limit. If you pick the wrong pick the wrong partition ID, you might exceed 20 gig logical partition. And that means you have to repartition. Well, bad news for you is you cannot repartition Cosmos DB containers. You have to recreate a container and move your data with the new partition ID. So that's going to cost you. You might have hot partitions. You might, like maybe one of your partition has 500 items. Maybe the other partition has, 500,000 items. So that's going to create a lot of traffic problems, and it's going to be costly for your application. If we try to explain the partitioning in Cosmos DB, it's really organizing data better so you can find what you're looking for easy. For example, look at this garage here. I wish my garage was like that. And you don't have to really live in this house to know that if I'm going to ask you, can you go get me the screwdriver? You know exactly where a screwdriver is. So it's going to take, you are not going to think that much. You are not going to waste that much time to find what you're looking for here. Same with this closet. If somebody's going to ask you, go get me the, red shoes or the white jacket, you know exactly where they are, and you don't even leave this here. It's right in front of you. It's organized well, and it's not going to take that much time. I guess that's one of the best examples. I used to work in a customer service long time ago in a computer service. And I used to work in the third-party shift, and sometimes I used to get those calls from the technical services. They are saying like, "Oh, can you find me this computer X in the data center and reset it? I cannot log in." My data center wasn't like that, and resetting the button, I can do that in 5 seconds if I can find that computer. And it's gonna take a lot of, I'm gonna waste my time, type it. Sometimes it took 5, 10, maybe 20 minutes to find the computer to actually press that button. So I guess what I'm trying to explain here is we don't really think about this that much when it comes to data. How about, organizing the data in databases? If you think about the SQL Server, usually what happens is, Dev creates the table. We are lucky if it has primary key on it. And then, they start to push data in it. And from there, it maybe works 3-4 months, 4 months, everything works fine. Then, we might get a call. The DBA gets the call and say that, what, this application starts to kind of slow down. What's happening? DBA goes and looks at the table and figures out that there's no indexes on it. So he puts some indexes on it. Then, maybe we are good for another 2-3 years. Then our devs comes back to the DBA and says that, what, this thing is getting slow again. What's happening? DBA looks at it. It looks like we have a lot of data. So he says, okay, it's time to actually create partitions. Usually that is the workflow in SQL Server. The Cosmos DB is the other side. So you have to actually create the partitions in the beginning, not when you need it in the last second. To do that, you kind of need to know your data. You need to know like your where clauses, how you can actually search with data, so you can actually pick the right partition ID. Also, you kind of need to check out if your application is going to be a write-heavy application or read-heavy application. For example, if you have an IoT application, right, your device is really doesn't going to read any data. It's always going to push data. So it's much better for you if you actually create a really unique partition ID, maybe the ID of the IoT device, or maybe you might need to actually go even unique than that, because that's going to make the transactions much faster. But if it's read heavy, then that means that partition ID that you are going to create, you kind of need to know partition ID to actually read that data, because if you have the partition ID, things are going to get much faster. Also, things are going to get much cheaper. So those two things are important. And the other thing about the partition is partition ID will be hashed in Cosmos DB. That makes the distributor requests, that distributes the storage, and it's intelligently route the queries for efficiency. So it's pretty important to pick the right partition ID. Now, if you go back and look at our example, this was our example here, right? So we were actually, I was showing the physical partitions with Lego blocks. So in here, looks like we have 2 in each data center. Now, I want to change that analogy a little bit. So rather than using the Lego blocks, we can actually say that each Lego block is a physical partition and they are like a container ship. This has really nothing to do with the container technology. I'm just talking literally a container ship. When you create a database in Cosmos DB gives you one empty container ship. And that is your physical partition. It's your responsibility to actually organize your data and load in this ship. So here you can see each container is going to have the partition ID. So in our case, we are really carrying cars. So if it comes to the partition ID, probably what I'm going to pick here for the car is going to be the VIN ID, because that's going to be the unique ID for each car. And that means that each container here is going to have one car in them. I can't store any kind of information about the car, all the messages, maybe all the alerts, all the warnings. As soon as I know which container it is, I can actually go, open it, and my data will be in it. So If you are going to try to do maybe pick a wrong partition in this case, what might happen is you are going to say, rather than picking a VIN number, maybe you are going to say that, what, I'm going to organize my data by model number. Then that means you are going to have one huge container here. When you open that container, there's going to be all the cars in it. So that means that it's going to take much longer for Cosmos DB to find what needs to get updated, what needs to get retrieved. And that means more CPU, more memory, more I/O, and more money. So that's why you kind of need to pick the right partition ID. So your solution will be, first of all, rather than fast and other stuff, it's important to be cheaper, affordable. That's one of the main problem. Most of the people picking the wrong partition ID, and they say that Cosmos DB is expensive. Cosmos DB will be expensive if you pick the wrong partition, for sure. So if we give you another example, which I say that those e-commerce websites, let's say we have a marketing, and we are selling all kinds of stuff. So if you think about that model, what do we have here is we are going to have users. Each users are going to have their orders. We are going to have tables about probably the reviews. And of course, we are going to have shopping carts. So in here, you are really seeing 1, 2, 3, 4 kind of data models we need to make this thing work. And if you think about the partition ID, we are going to have a lot of candidates here, right? So for users, you might have picked the user ID or the location of the user as a partition ID. Orders, you have some options. Products, we have some options. So how do you pick that? The best, I guess, idea I can give you here is don't think like it's a SQL server. Because if you think about a SQL server, probably you're going to have these 3 products or 3 databases. I mean, the 3 tables, and you're going to kind of join them by product ID, user ID. But in Cosmos DB, it's not going to be like that. So first of all, in Cosmos DB, you cannot join container to container. If you think about, for example, Amazon, right? So when you go to the Amazon first time, the page opens. And in the main page, it's kind of useless. It just shows what's really happening in the website. You kind of need to pick the category first. So if you are looking for example, books, you might need to pick the books, and it's going to show you more categories under that. If your database is Cosmos DB, well, that's going to be a challenge for you because, for example, if we have the products and you're going to pick the product ID as your partition ID, well, by picking the category, it's really not going to help you to, show which products you should select in the next page. In cases like that, it makes sense to actually multiply your data rather than, putting everything in one container. So you might have actually 2 containers, one named products, and you actually get the partition ID by product ID. And you might have another one, and you can call that, I don't know, product categories. And that one will be the partition ID can be product category ID, and you can have all the products under that. So many people won't like that because then you're going to have product information in 2 places. If you need to change the product, for example, name or the price, then you have to go these 2 places to change it so they will kind of match together. That is kind of like a no-no in a relational database. In Cosmos DB, that's what you need to do if you want to keep this affordable, because there's nothing wrong with actually putting them in 2 places. Cosmos DB has tools to actually sync them if you need to. So you will have a product categories. My user goes and picks a category. Its category ID is my partition ID, so it's very cheap for me to actually go and get all the products under that. And also, I don't need all the product information. I need the product name, maybe the price, maybe the picture of the URL. That's all I need. I don't need the whole description of that anyway. So then, my user picks the category. I list the products very easily and cheap. Then my user is going to pick the product. Now I have the product ID. Then I can actually go and look at the main table with the products, and I will search by product ID and get all the information I need on, for example, in Amazon, you have the picture, description, reviews, all kind of stuff. So you can get and pull it from there. So the way that you are going to actually organize data in Cosmos DB is much different than relational database. The next I'm going to cover here is with the partition ID is IoT. So as I say before, in IoT, we have sensors, and they are the one which is pushing data. So in many cases, you might not have good candidates for partition ID. For example, let's look at here. We have the Night Rider here, and believe it or not, IoT devices, people actually think about it in 70s and 80s. The problem was technology wasn't out there to actually make it happen. But anyway, so in Night Rider, actually, we have some IoT devices out there, as you can see. So the problem here is, let's say one of those IoT devices is actually sensing the maybe temperature of the engine, and it's just sending to the database. Well, maybe it does every 20 seconds, every 30 seconds, and usually that's kind of the same data. And this IoT device might not have that much information. What is it going to have is probably the temperature as a number, and maybe the device ID. That might be it. There's not that much out there. And in cases like that, you might need to actually create synthetic keys. And synthetic keys are, for example, let's say my device ID is Night Rider. And what else I know about this, rather than all the sensor numbers, is maybe the date. So what I can do here is, I cannot just pick for example, year, because that means all the cars from 1985 is going to write the same partition. That's not going to work, and that's going to create, hot partitions. In 1985, I might have 20 devices. In 1986, I might end up with maybe 1,000. So it's not going to work. But what we can do is we can try to maybe combine what we have and make actually a synthetic key. In our case, what we can do is, okay, we have a Night Rider, we have a 1985. So, then we can kind of combine them and create a synthetic key. If we want to make it more unique, if we have a lot of devices, we can do that. What we can do here is then, okay, we use the same thing. We have the device ID, we have the year, and our SDK maybe generates a random number from 0 to 200 each time it tries to write. That will make this thing really fast because it's going to be really unique. But the problem is, if you are going to try to read this data, you are going to have a lot of problem because there's no way you are going to be able to guess this number. That's a random number. But if you are worrying about only a write-heavy application, this might be to go. Another idea you can do here is you can just hash. For example, in here we have the win number. If you hash this win number, I should be able to create that hash if I try to read it again. So that's another kind of option you can use. All right, I think that's all I have for you today, and I hope everybody learned something new today. And as I said before, I can answer any of your questions now. You can just let me know if you have any questions later from any of those platforms. Thank you. I hope everybody enjoyed.
Awesome, thanks. There were a few questions that were asked along the way.
Okay.
I think you covered most of them, but let me scroll back a little bit. And we have a few members of the group that also made an attempt to answer it. So sure. Let's have you at least address them here. So first one is Cosmos DB storing only transactional data like in most SQL Server cases, or can it store objects like documents and emails in there as well?
Yeah, you can do the documents, but I mean, it depends on the size. You can save them as, so I'm not sure what you mean by the documents, but for example, I put the Stack Overflow in my Cosmos DB. So each post is an HTML, it can get really huge. So I save it like that, and it can do that.
Yeah, so the follow-up to that was, I'm not saying metadata about the documents, but also the original documents. Also, what is the index search platform behind it? Is it flavor of Elasticsearch or something else? I think you got into the indexing a bit. So I think
so indexing, yeah, you can check my blog about indexing more, but there's like 3 types of indexes up there. So there's one for numbers, there's one for string, and there's one for the geospatial data. But that kind of depends what API you use to. So mostly I'm familiar with the SQL API, but MongoDB can have its kind of own things.
Yeah, actually, I don't know what I'm thinking. The person that asked that, Robert, if you have a mic, you can come off mute and see if we got all your questions answered.
Yes, hi. Thank you very much. I think Bob has answered some of them along the way, and also Hasan, you said that the database itself can store those documents or emails. One question maybe that I may have is what would be the maximum size, or would there be a performance issue if the documents were larger? What do you think the recommended or expected largest size would be to store in the Cosmos DB directly?
Yeah, I mean, it's not really the top of my head what's the maximum, but I think that kind of works the same way with the SQL Server. You know, for example, if you're trying to save the image, you don't want to put the image in the database. You want to put the image somewhere else and put the URL in the database. So I think that kind of applies to Cosmos DB too. And I wouldn't recommend to put like very large objects in Cosmos DB for sure.
Thank you.
Were there anybody else have any questions? Feel free to come off mute.
Yeah, I've got one. This is Jim O'Neill. I noticed you started out with the SQL variant or the SQL sort of interface on top of Cosmos. One of my major kind of questions is when do you make the decision point whether to just stick with a SQL database or to use Cosmos if, for instance, it is really schematized data that you're working with? Would you ever use Cosmos if you just had schematized data?
So I guess in that case, I will say really your environment, because most of the devs pick Cosmos DB because sometimes they don't want to deal with DBAs, unfortunately.
Okay.
So I mean, if you want like a very fast development, if you pick the Cosmos DB, you don't need to worry about the DBAs. They try to figure out what you are doing and other stuff. So if you want like fast development, they pick Cosmos DB. Even you should pick the SQL Server.
Have you had any issues with the SQL Server interface in terms of compatibility with what you might have with SQL Server proper, like certain constructs don't work or aggregates or things like that?
I mean, it really depends on the size of your data too. So SQL Server can actually store NoSQL data. It supports a JSON document, so you can store the JSON in SQL Server, right? So if you have an on-prem SQL Server, and if you don't have that much data, you really can store the JSON document in SQL Server, and you can actually retrieve that data from SQL Server too, as long as you are not trying to create like an IoT device. It's a huge big data in it. I have good experience with it, but the problem is most of the DBAs do not like JSON in SQL Server, so you kind of need to deal with that. And also, you have in-memory tables. You can kind of do all kind of stuff in SQL Server really fast, close to what Cosmos DB is trying to do here. So, but as I said before, then you really need to deal with, DBAs and give them good, I guess, reason why you want to do this.
Okay, thank you.
Yeah.
Anyone else? Awesome. Well, thanks very much for the presentation. Definitely. So I've been learning Cosmos a bit because I'm studying for the developer exam, the Azure developer exam. I haven't personally used it, and it's such an interesting database. So thanks again for presenting. Just another reminder for anyone out there who is a presenter, please contact us if you want to present anytime, and we'll be sure to get you on the roster. And thanks everyone for joining.
Yeah, thank you.
And Hasan, if you could hold on for a second.
Sure.
Let me stop the recording here.